check my step. It's a simple line, but yet a beautiful reminder that in learning, and especially in design research, mistakes are not failures, but valuable steps toward deeper understanding. And that's precisely what today's lecture will explore. How we can design learning that genuinely make an impact and foster meaningful understanding in mathematics. Ladies and gentlemen, we will now move to the highlight of today's event, the general lecture delivered by our outstanding speaker, Associate Professor Dr. Marteen Dolk, with the theme Design Research in Action, Creating Impactful Learning and Deep Understanding in Mathematics and Science Education. Allow me once again to serve as your moderator for this session. As we know, our speaker is an expert in realistic mathematics education and design research from Utrecht University, Netherlands. And according to his Google Scholar, Dr. Marteen Dolk's research has received over 2,000 citations with an age index of 19 and I-10 index of 31 as of 2021. And throughout his research, he has inspired educators around the world to design classroom learning and connect theory with students' real experience. Without further ado, please welcome Associate Professor Dr. Marteen Dolk. Okay, you can start your lecture, sir.
I'm a teacher. I have a loud voice. So the question is, can you hear me? Can you hear me? The thing is, of course, I don't use this. The thing is, of course, if you don't hear me, you cannot answer the question. I always say when I start, saya tidak bisa berbahasa Indonesia. What is mathematically an inconsistency? To say in Bahasa, I don't speak Bahasa. And as mathematicians, those are the things we like. Now, sitting here, I was looking at the mathematics. One screen was broken. So immediately I was thinking, hey, fractions. If 1/3 of the screens are broken, or 1/4 of the screens are broken, what's happening? There's a lot of mathematics there. Now, the other thing that's interesting, 9, and it ends, and then you show a clock. So that is intriguing to work with young children, because there are two ways to formalize, to visualize clocks. And so, is that clock meaning it ends sometime? Or is that clock meaning it ends at 5 o'clock? That's something to debate. But at the beginning is the calendar sign. And that is only an icon to say, what day do we do it? So there is a lot of different notions going on here. And if you look around you, the world is full of mathematics. And we all know that. And that's what you have been using. So now I want it. I need to show that screen first. So, as a speaker, this is the scary moment. Will my computer work? And so far, there it is. This is a little bit of Utrecht, where I live. Fiona knows Utrecht very well. Dr. Fiona has stayed 3 months. 3 months? 4 months! Time flies. 4 months in Utrecht working with some of my colleagues. She might tell you where this is. It's a nice test for her. Or she might tell you where this is. This is very close to my home. And I see the lock. The water goes 20 centimeters or so. Water in itself could be interesting. Yesterday I was in Padang and I saw a sign plus 6.38. And so immediately I said to myself, could water be a possibility to work with negative numbers? In the Netherlands, we have areas that are below sea level. And we have NAP, that is normal Amsterdam. It is what we think sea level should be. So the sea could rise from above, 1 meter above Amsterdam level to 3 meters below Amsterdam level. And those things happened constantly. It could be a context. But I said that only works if children understand water levels. In Padang, Professor Fauzan told me 5 meters is the maximum height they expect at tsunamis. So 6.38 is a safe area. If that helps to use negative numbers and operations with negative numbers, I don't know. But it is a difficult thing because you constantly look around what in an Indonesian society would help children to work with negative numbers. This is a little bit of Utrecht. We have a lot of water and children learn to swim very early. Just precaution and safety. Because sometimes children fall in the water. We have a lot of bikes, but not all bikes are constantly used. So this is a bike very close to my home where the flowers are around it because the owner didn't buy it for a long time. Could have been my bike, it is not. And this is the mill that is next to my house. Utrecht has 2 mills, but the Netherlands, of course, used to have a whole history of mills. The nice thing about mills is that with those wings, the millers had a language. The way they put the wings, the way they put sails on the wings, had a whole series of language. Most of those mills were far out. And if they needed a doctor, then you first had to go by horse to the village. Then you had to get the doctor, you had to come back. And so the millers had a sign, need of doctor. Probably it was a dangerous profession, because why do you have a sign for something if you don't need so often? But sorry?
Near the corner of your house, eh?
This is next to my house.
Yes.
Yeah.
This one is still working?
It's still working, but as a, let's say, a showpiece. To keep it up, they need to run it at least once a month. And if you're a miller in the Netherlands, you need to run a mill at least once a month. Otherwise you're not a miller anymore. And that is just to make sure that all those mills that are working are still used. This is a mill for grain. So there are big stones where they can grind flour. Other mills are water mills, just to move the water going on. So there is a lot of physics in all this. Just imagine how you change the power of the wind into grinding flour. And so there are wheels in between. That is ratio. There are movements, so you have power. There's a lot of steady in it. Interestingly, I don't think we use it. This, of course, you all know, the Netherlands is a flower country. But sometimes you also find lecturers from Indonesia. Basil is very happy with a lot of cheese. So, I have been reading a lot of your proposals, of your ideas. I've been reading a lot of your questions. I received about 30 questions. If we talk about every question for 10 minutes, that is 300 minutes. And we simply don't have that. So I cannot answer each individual question. Plus, I already had a lot that I wanted to talk about in the morning. So don't expect that each of your questions will be answered. Also, don't expect that in one day I can remember each of your research. It's on my computer, I've been reading it, and I've been trying to understand the big line, what is common amongst all of you. And so, a lot of my remarks are more general in nature. I hope that is understandable. When I think about design research, I think it is about design. It's about research, and the combination is something special. And so we have to think about design, we have to think about research, and then we have to think about what is design research. Now, we had a project a couple of years ago where we worked with teachers. We had 10 schools, what we call rural schools, but the whole Netherlands is more or less one urban area, so what is rural in the Netherlands? We worked with 10 schools. It was a couple of years project, and we first worked with teachers of 2 grade levels in all these schools. And the next year we worked with teachers of all grade levels, higher grades, in all these schools. And so we tried to also to create a connection, a network. And the idea was that teachers would discuss what they find difficult, they would come up with ideas how they might change it. One of the teachers would try it, another teacher would try it, and slowly we would get to a solution of that problem. So it started with real problems of teachers. For you as PhD students, that is not always easy, because starting with a problem means you need to know education very well. And if you just did your bachelor's and then you did your master's and now you're starting on a PhD, you might not have that much experience in school. And when I was reading it, some of you started in, I know a nice context. And some of you wrote about, this is difficult in school. There's a big difference. Now, these teachers started with problems. And so we said to the teachers, let's make minor variations to a problem and see if we can change that. And the textbooks that they used are not good textbooks. Let's put that first. It was not a very helpful textbook. So, thank you. One of the things was that the textbook would contain rows of problems like these. And can you imagine what students do? They start with the first problem, long division. Then they go for the next problem, long division. They go for the next problem, long division. What I call, they are human calculators. They are not thinking. It's very hard for a student to take a step back and to say, what is this page about? It's not common for students to do that. So these students solved all these problems, but they learned nothing. And the teacher said, how can I change that? How can I make sure that I move away from only having students to solve problems to getting students to think about it before they do it? That was the main question. How can I change from calculator to thinker? And that's something we all love if that happens in class. So, long discussions. Teachers have a lot of different ideas. I went too fast. So, what teachers discussed is that they say all these products are somehow related to partial products. Partial products is a big idea. It's something you use. Partial products are important. And you can visualize partial products. That is important because later in secondary, you can use it if you want to talk about x plus 2 times x plus 5, That's always difficult for students, but with a visualization of this, you can do that. So working on this is important. And there are many moments that in class they have already been working on partial problems. Now, they looked at this and the teacher said, what about this? We put a box in the middle and we asked what problem would support you to solve all those other problems. And the idea was that if you first ask for that they would start to think about what relates all these problems. What is the connection between all these problems? That was the theory we had. If we ask them about connections, maybe they do something before they calculate. And interesting, it worked in the sense that students first answered what problem was in the box. But when the teachers used the word supporting problems, a whole group of students were insulted. I don't need support. I can calculate everything. And so language was important. Using the word supporting was not helping those people who are very efficient in calculation. We needed to find another word to make that happen. But it moved from only calculation to starting to think. And in that sense, teachers were very happy and thought it was a success. This is a very short design cycle. We know what is happening, we know what the problem is, we think of something what in our dreams will work, we try it in class, and we look back, is it good, or do we have to change it a little bit? It's a small design cycle. What teachers in a group with help perfectly could work on. Now, I've been talking English the whole time. Is that working for you? Can you follow me? Am I talking too fast? Do I say in a very fast voice? So, I want to hear that. Are you okay with my English? Can you follow me? Because if not, we have to go slower and we need some help of translations. What to me is important is that you can follow the conversation, not if you're good in English. Yeah? All of you okay? Okay, then I go on faster. So, another problem. The same group of teachers, this was in their textbook. Didn't even really work. Once again, the students were not really thinking. The manual said, start by talking about these problems. Well, that doesn't work, the teacher said. They only calculate. They don't think. And so the question was, what can the teachers do? What can you do to make students start thinking with this kind of problems? Talk to your neighbor. What would you do? What do you think might be helpful? Talk to your neighbor. Talk to your neighbor. your name is? Kuliah. Yes. Interesting question. So here we start talking about research. What do I mean by student thinking? You understand what calculation is. So what is it that we want students to do here?
Students are thinking when we calculate research. That's why I'm asking.
I'll come back to the question. But first I want to hear ideas. What would you do to help students here? Anybody had a nice partner who had a great idea? I've heard you talking, guys, so any ideas? What did your partner suggest?
Problem like 12 multiplied by 15 equals to 9. 6 multiplied by 2 multiplied by 15 or 5 sorry 9 6 6 multiplied by 30. I think this is just calculation. Meanwhile, student also think I think also do some thinking to relate the calculation.
Because what do you also related to Dea's question, what do you mean by thinking in this case? What is the difference between calculation and thinking? Why would the teachers be so unhappy here? That is what we have to analyze. And that is your task as a researcher. If a teacher says, I'm not happy what's happened here, you have to analyze, often very quickly, what is so unhappy? What is the issue here? And what can we change? So, names. Ellie, as Ellie, what did your partner say? Yeah, Bahasa is okay. I'm a wonderful translator. Okay. More ideas. More ideas. What is happening? Is that why are the teachers so unhappy? What is the difference? Because I love your question. What is the difference between calculators and thinkers? Is that 2 times 3 times 5 times 8, students do 2 times 3, 2 times 3 is 6. 6 times 5. 6 times 5 is 30. 30 times 8. They go from left to right. If I look at that problem, I say 2 times 5 is 10, 3 times 8 is 24, 10 times 24 is 250. I switch orders to go for easy numbers. 12 times 15, I say that is 6 times 30. Much easier than 12 times 15. 6 times 30, I could do again, doubling, halving, 3 times 60. By using strategies, I make my life easy. By just going from left to right without thinking, I encounter more difficult multiplications. And that is where the teachers were protesting. That is why the teacher said they are calculators, not thinkers. They don't look at the numbers. And that's a big difference. What I want is that 4 times 2 times 9 times 5, the 2 times 5 hits them. Like there is some glare of whatever around it. Oh, 2 times 5 is 10. What I'm left to is 4 times 9. 4 times 9 is something I know. And then times 10. I know how that goes. That is easy. I can do it in my head. Think before you begin. Look for numbers that make sense. That is what teachers want. And so, the big idea that they want to talk about in a way is cumulative property. I can switch order. It is the big idea of strategies, doubling and halving. And what teachers came up with is that instead of that introduction that is there, they started to ask these questions. And the hope that the teachers had, big numbers ask for thinking. Small numbers allow calculations. 2 times 89 is something students hate. But 2 times 5 is nice. And so, even if some students don't do it, but if you tell them, I did 2 times 5 and then times 89, the others think, oh, I can do that. And so the philosophy is that even if they don't do it, they are admiring Novi because she did it. And they think, I can try that again. So the philosophy is big numbers. Big numbers help to start talking about different solutions, compared to small numbers that don't invite any thinking. There's the theory. And the practice was in this example. And so the answer to Leah's question, what is the difference between the calculators and the thinkers, comes to the fore in 2 times 89 times 5. A calculator does 2 times 89. 2 times 89, 2 times 89. You see them being confused and hate you. The thinker already says, I know it. Can we go on? I know it. So that is the move. It's again a small design research cycle. Those teachers didn't think about design research. We never talked about design research, but we did design research. Because we talked about what do we know that the children are doing, what is so difficult, what is the problem. Then we designed something where we said maybe it's change. We have a hypothetical learning trajectory. We have theory. The theory was big numbers force students to think. It's a simple theory. was also a simple problem. Big numbers. And from that theory, we tried something where the expectation was we have children in class that will use 2 times 5. And then we start to talk about it. And teachers were very happy because it worked. And they also understood that that theory, big numbers, was something they can use in many more situations. And they could talk about it with other teachers. So the theory was not just in this context, was not just in this situation. The idea, big numbers, was something that I can transfer to many different situations. How do I build a constraint, a difficulty that forces students to think? And that idea is something that I always have when I build context. I want a context that gives a suggestion what you can do, and that has a difficulty that forces you not to do the easy way. So in every context I think about constraints and I think about suggestions. The constraint is the big number, the suggestion here is the 2 times 5. So, research always starts with a question. You have a question that you want to solve. Those teachers had a simple question. My students are just calculating, not thinking. It's a simple question. And people have different questions. Politicians have different questions than teachers. Textbook authors have different questions. Every group has different questions. If you later on ask for funding and you look at the call for the funding, you will see there are certain questions. There is a goal for the research. Now, this is a question that's always been debated in classrooms, that's debated in newspapers, that's debated everywhere. Video games are dangerous. Are they dangerous? It is a research question. And so there are many of those questions. Is approach X better than approach Y? Are the students in 2020 smarter than the students in 2025? Is the results of mathematics education in Indonesia in 2014 better than the results now? Many of these questions, and I say these are yes and no questions. Because the answer is yes, it's true, or no, it's not true. Politicians often ask for this kind of research. It's very legitimate research. If you want to compare groups of students, that's important. And being able to say that what we did in 2014 and what we do now, how that compares, is good research. It's not design research. Now, other questions, let's change the questions a little bit. They ask not for yes, no, but they ask for information. What are the characteristics of a good school? One of the characteristics is a good leadership. Team meetings. But what are the characteristics? What class size is better? A huge discussion in the Netherlands every time over. What is a good class size? Some research says 15, some research says 20, some research says 25. What never is compared is what do I want to happen in that class? What is the kind of education that I offer? Because the background, the kind of education, what do I call good education, what are the results I want, defines what the class size is. And so, as soon as you see these results, people start to talk about, yeah, but you have a different class in mind. So, it's not easy. These are questions where you get different answers, not yes, no answers. Now, there are more questions, like this. How can we introduce negative numbers in schools? This is a question I always encounter here in Indonesia. Why? Because you start with negative numbers in primary school, we start with negative numbers in junior high school. We start much later. How can we teach students to create meaningful graphs? Etc., etc. The answer to these questions is totally different again. The answer is in theory. And it is in design. And so, depending on the kind of questions you ask, you get a different form of research. These are how and why questions. And reading your short description, if there was a question mentioned, all of you had how or why questions. These are related to design research. Now, another example. And this comes from a research study by people like Paul Kopp, Kuno Gravenmeijer, and more people. What I describe is a very tiny part of that research. The research is much wider. But one of the problems was that students, 83 minus 5, they would say 79. So, first of all, talk to your neighbor. What happens that students say 83 minus 5 is 79? How come? What is the background of that problem? Why do students say 83 minus 5 is 79? Talk to your neighbor. No shouting, no shouting. So, the pedagogy of my class is that if you shout an answer, they don't think. And I want everybody to think. So I don't want in my class people shouting answers. I wait. And if people have had enough think time, we can continue.
Jalan-jalan tuh. Mengapa banyak siswa mengatakan bahwa sama dengan 79? Apa konteks apa yang akan menolong siswa untuk memahami perbedaan 83?
I often look around and I see, do you have enough time or do you need to continue talking? Because as a teacher, that's always very difficult.
Iya.
Okay. Can we
83,
come together again?
83,
Ibu Novi, you've been talking with your neighbor and I don't know your name.
Nur.
Noor. Noor. You've been talking to Noor. What did Noor say that you said, oh yes, that could be? And you can answer in Bahasa if you want, you can answer in English.
Maybe 83, 83, 82, 83, 82. Yes, maybe mungkin
Okay, guys, let's listen to Novi.
Oke. Mungkin kenapa siswa menjawab 79 karena kan dari 83 dia menghitungnya dari 83 jadi mundur ke belakang 83, 82, 81, 80, 79. Jadi jawabannya 79. Itu mungkin karena mengurangnya dengan hitung ke belakang. Kenapa dia menjawab 79? Mungkin seperti itu.
From my perspective, it was very nice because in the beginning you were just talking and slowly I saw people using their hands. And I saw people counting on their hands. And we all understand what Novi is saying. So, in higher mathematical terminology, the problem is student count objects. And a finger is an object. It could have been beads. And they call the first object they count 83. So that is the issue. Now the next issue is, how can we solve that? What can we do so that this doesn't happen? I cannot take away their hands. So what can I do? Any ideas here? Any ideas? How can you solve that?
Tidaknya ngapa sama dengan 79?
So talk to your neighbor. How can we solve that? What ideas do we have to solve that?
Diskusikan lagi bagaimana menyelesaikan masalah itu.
Anak kita kalau mau belajar di sekolah itu kan saya udah kalau aku tengok padi tulis
There is not enough time.
pengurangan tuh kita
Let's put that forward. Paul Kopp and his group
aku tengok dia tulis kan belajar
was a group
belajar
of,
menghitung
I think, something like 10 people.
1, 2,
There were at least 4 seasoned researchers.
jangan 10
There were student assistants. There were more people. And so discussing what to do is a team effort. Different than your PhD study, because that is you alone.
kalau di sekolah
Yeah.
tidak tahu
You have a supervisor, but your supervisor has to supervise all of you. And I don't even understand where they have the time to do that. So you're on yourself. But Paul Kopp had the whole team. That makes it, of course, easy. Let's do this, let's do that, let's do that, let's do that. A part of the analysis is 83, 82. But in reality, that is not what you count. What you count is 83,
yes
82. You count the movement, not the object.
yes
So I need a context that would force the constraint, that would force children to count the jump. That is what we are looking for.
harusnya kan
And their suggestion was measurement. Because if this is 83, 82,
Yes.
81, and I have not so much balance, so that's difficult. 80, 79.
Cara
So
belajarnya.
measuring, the idea was if I go to a measuring context, I force kids to think about the movement. And so they introduced a context of measuring the table, measuring the classroom. You had to introduce the idea of what a measurement was. So in their research, they really researched the introduction of measuring. And all of a sudden, 83 minus 5 becomes making jumps
Oh, seharusnya
and
ada
avoiding
kata-kata
this
ngomong
object
bahasa
count.
asing.
This, of course, was the problem, and Novi already explained that perfectly. And the idea of measuring, the idea of a number line, didn't start out of nothing. There was already a researcher in Japan, Atano, who was doing that for a long time. I think his research is somewhere like 1960 or 1970. There is a neuroscientist, De Hane, in Belgium, who says children think in number lines. People think in number lines. If they think numbers, in their head, they have not a straight line, but they have something like that. And so they have been reading up on how do people see, and they use that. And this is where they reported that. Supporting students' development, measuring conception, analyze students' learning in social context. So it was a much wider research. This is a huge monograph where they talk about all these things. And I wanted to know the title yesterday, and with some searching online, I came across of the whole document, because there are always universities that publish something that should be bought, but it is still online. It's very interesting to read, because between the lines you see how they did this research, how they report it, and it is always very helpful to understand that. At the same time, Paul Kopp is an incredibly difficult writer. It takes a lot of effort to understand what he is writing about. He writes very high-level, dense academic text. So it's not the first article. Paul Kopp is not the first author to go to start reading English language articles. There are easier ones.
Yeah, just one. It's very interesting page jurnal Jeremy. Ya, Jeremy jurnal yang paling bagus di dunia untuk education. Ini tulisan bagus sekali tentang riset bagaimana riset dari orang Amerika dan di bawahnya beberapa miliar orang Belanda. Nanti kita akan saya cari yang kita cari artikel yang full ya, kalau saya baca ya. Karena jurnal ini tidak mudah untuk tapi kalau ada takut di sini bagus sekali. Nanti dia bisa jawab. Oke. Just mention that we are going to download it.
So, as a researcher, you have a field of possible research types. And it depends on what your question is, it depends on what you want to do. And simply you could say, and it is simply because there are way more ways to do that, you could say, what is the degree of closeness? How much freedom do I have as a researcher during my research? And in some styles of research, you don't have any freedom. You just have to do it. In some styles, you have a lot of freedom. And the other one is the amount of influence I have as a researcher. And so if I look at the field of research methodologies based on closed and based on influence, I could say a survey with closed questions is as close as possible and definitely doesn't give you any influence. Do you like mathematics? Do you like addition? Do you like subtraction? Do you like multiplication? Do you like division? I get answers. I will know that I can report that children don't like mathematics, but they like addition. Of course, it doesn't give much information. Teachers will say, okay, fine, doesn't change my classroom. And you as a researcher, you have that set of questions that you make, and once you have the set of questions, you can change anything. You just have to do it. So it's closed, and you have no influence. An experiment is rather closed, but you have more influence. Because now you describe of something you have done in classroom. And teachers can read about it and can say, oh, I can do that in my class, yes or no. A case study is a description of what happens in class. So the influence is much lower, but the freedom that you have as a researcher is a little higher. And in that corner is where design research is. You have more influence, and it is rather open. In a survey, people will never ask, what was your bias? In design research, people can immediately talk about how biased were you as a researcher. Would I see the same things? And so the criticism that people have on different types of research differs too. And where in a closed question you can send everybody to do that, so often assistants will go there. In action research or in design research, that is different. And there, you will be in that classroom. The teacher will do things that you designed and will change it at the spot. And so that process needs to be very well documented. In interviews, you have a series of questions and then you try to analyze it. There are journals that will say, who did the analysis of the interviews? Oh, you yourself? We don't publish it because we cannot see how your bias is done. They want very strict rules about how to analyze those interviews. And so the bias is always an issue. And that is something that makes design research so much harder. Or at least reporting about designers. Because you have to somehow show that you as a person were not the influential factor, but it was the design and it was the ideas behind that. So why would you even do design research? And Kuno Gravenmeijer, who for many years worked at the Freundlich Institute, said something that always resonated with me. If you want to change something, you have to understand it. If you want to understand something, you have to change it. And that, to me, is why design research is so important. Every country has things that you never discuss because you find it normal. Everybody accepts that. In the Netherlands, in our thinking about building up mathematics, people always talk about the numbers 1 to 20, 20 to 100, and larger. American colleagues always say, why the heck do you do that? in Bangladesh, they talk about 1 digit, 2 digit, 3 digit, kalas 1 1 digit, kalas 2 2 digits. And so I asked them, what about 5 million minus 3 million? When do you do that? Is that a 1 digit number? I learned the most about Dutch education by being outside the Netherlands. Because I see things being done differently, and immediately I start to wonder, why do we do that not this way? Seeing how things change help you to understand how it goes. It's also the philosophy of teachers visiting other classrooms. That to me is the idea behind design research. I want to change things so that I understand it and I can write about my understanding. I want to understand things, therefore I change it and I can understand it. Understand is here the crucial word. And more formal, why do I do design research? To understand innovations and ways to implement innovation. It's a formal argument, you could say, why I do design research. So you could also say, from what works, is this a good activity, to why does it work? How does it work? That is that question about the theory behind it. And when I was reading your text, often you said, the theory is that it worked. And that is not the theory. The theory is that you explain me why it works. So if you write, my local instructional theory is that students were more interested, I'm not happy. Because that is not a theory. The theory is students were more interested because. It worked because. And so in half of your papers, I think that your local theory was not good. To be tough. And if I would be a reviewer of your articles, and your theory would only be, yeah, the local instructional theory is it worked, I would refuse that paper. I need to see that because. It's crucial. So you can write about it in 7 other ways. Why do we do design research? Why do I pay attention to this? Because in many educational circles, design research is not automatically accepted. People will say, but why do you prove something? How is that working? Is this really a good research? Is this... And so you have to be able to defend why you do this research. And you want to write about it shortly in your thesis or in your articles to be able to explain what is your philosophy behind this methodology. Now, if you publish in Professor Schultz's journal, those reviewers know about design research, so that is not a problem. But if you go to a journal in Korea or you go to a journal in Poland, you might encounter reviewers who says, is this even research? And you have to be ahead of that. So depending on the journal you write for, you need a paragraph, why is this good research? Why do I do this? And so, when I think about design research, I always think about there is design research, there is hypothetical learning trajectory, and I go back to articles by Marteen and there is lesson studies. And somehow I try to combine those three things. Why lesson studies? Because I want that implementation. I don't do design research because I want to understand it. I always do it because I want to improve something in schools. But that is me. In your thesis, I think that if you only do design research, you're already doing a lot. Ever seen this? Know it? Who says I can explain what this is? Who says I've no clue what this is about? That's interesting, guys. Either you can explain it, or you have no clue, or maybe, yeah, a little bit, but I'm not sure if I explain it right. So I want to see fingers, and one of the three should be you. Question 1, I totally understand this, I can talk about it. Question 2, I have no clue. Question 3, I can say a little bit, but not everything. Question 1, I totally understand it. Question 2, I have no clue what this is about.
Ayo calon-calon dokter yang mau tamat tahun ini harus nyawa pada dan bisa jadi dokter kalian.
Question 3, I know a little bit, but I'm not sure I know everything. It's very interesting because you pick one of the three groups. So that's difficult, isn't it? What can you tell us about this? You're Indonesian, so you need a microphone.
Thank you. This is a cyclus design experiment. K is knowledge, and D we doing design. A is experiment. R research. Analyze. This is my reason. I know a little bit, but I can more explanation.
Do you have questions around this?
Yes, of course.
Give me one question.
In bahasa.
Oh, okay. We have one more translator. I'm fine.
Tolong. Begini, terkadang ketika kita melakukan sebuah siklus ini, kan ada tujuan yang tidak tercapai. Sementara kita melaksanakan itu harus disesuaikan dengan jadwal yang ada di sekolah, gitu. Apakah kita melakukan itu berulang-ulang sampai tercapai tujuannya, atau kita bisa ulangi lagi di tahun yang lain, tetapi dengan subjek atau siswa yang lain, gitu, dalam melakukan siklus ini? Mungkin itu yang ingin ditanyakan. Oh, boleh.
Can I first get the translation? And then...
In bahasa.
Yeah. Let's first translate that. Then I'll get to where we are.
He said that when we do this cycle of design research, we have some objective, some of learning objective that students must accept. But sometimes when we do this, there's an objective that students can't accept. Our learning objective is not reached like we want. So, should we redo all the cycle in the next year with different subject, or should we do it with the same subject, but it's difficult to do because school has their time.
Okay. You wanted to answer that? You wanted to answer his question? Oh! Another question, yeah? Wait a minute. I can only handle one question at a time. Anybody who thinks I can answer that? There is not one answer to that. So, if I'm working on developing understanding of fractions, because 1/3 plus 1/4 is difficult, I have a theory. My theory is that if I help students on a double number line, I now talk our talk, not students' talk. If I can work on a double number line, on the top are the fractions, on the bottom are whole numbers, meaningful to the fractions. So 1/3 plus 1/4, on the top are the fractions, on the bottom are hours and minutes. 1/3, 20 minutes. 1/4, 15 minutes. So 1/3 plus 1/4, on the bottom, 20 plus 15. That's 35. Yeah, but now I have to move to the top. That is the philosophy I have. That is the theory I think could work. The work of a double number line with whole numbers on the bottom. Now, that didn't work. I tried it, first lesson, didn't work. And the answer is simple. I have to redesign my context. And tomorrow I come back with a better context, where I think it works. And I can do that in this class. Why not? Marteen wrote an article where he worked with 2 students. And he tried to have those students do the work. And so every time he encountered the difficulty, he went to his study, he started to understand why it is difficult, how can I solve it, and he came back with a better proposal. I supervised students in Solo for a master's, and what we did was an ongoing cycle in conversation with 3 students to try to have them understand transformations in Marteen. So the same group can work. Of course, if I want to solve a problem that's very dedicated, I cannot ask that same problem to this group, because then I don't know what the influence is, what I did before. So I have to try it in either another group, or I have to try it next year. It also depends on whether your cycle is only one small problem, one investigation today, or your cycle is the whole Kalastika. So there is not one answer to it. I have to adjust to the situation I'm in. But in many cases, I think you can just try it again and go back to that group with a better context. Because often it is the context, it is the design. I always lose those things. It is the context, it's the design that will make it happen. No, it's my fault. I just killed those things. I don't like that. I also don't know why I use it now. So, and the question that I've not been asked yet, but the question that everybody always has, how many of those cycles do I do? And in reality, there is no good answer to that. If you have a plan, you have a dream, you try it in the classroom, and it is all wonderful, you only need one cycle. The problem is you have nothing to write about. It's much easier if it goes wrong the first time. Maybe even goes wrong the second time, and the third time you have something that is happy. Because that gives you a lot to write about. So I often say to master students, to PhD students, I hope it fails the first time. because it gives you a lot to think about, to reflect, to write about. Kuliah once told me, so I do it, and I do it a second time till I think it is about good, and I think my dream is now the perfect lesson, and I write about that dream. I don't try it anymore, because I really think that is how it should be done. And I can now talk about my theory as it has been developed. Is that answering your question? Okay, you have to think about it for a second. I like that. I like that. Now, you have a question. We still have not talked about what it means, but we will do that.
I have different thinking with this iterative or this cycles. Can be siklus di definisi atau apa? In definition many characteristic characteristic 1 move characteristic 2 and characteristic any other in classroom student classroom. Jadi kalau enggak ya. Maksudnya gini, jadi siklus itu apakah bisa didefinisikan hanya satu kelas, tetapi dengan banyak satu kelas itu banyak karakteristik, otomatis itu kan berarti siklus juga. Siklus untuk karakteristik yang tinggi, siklus untuk karakteristik yang rendah, siklus untuk karakteristik yang lainnya. Jadi tidak perlu melakukan siklus di berbagai jenjang. Apakah boleh didefinisikan seperti itu? Benar tidak terasa?
Your name is Pak?
Usman. Not Usman. Usman.
He asked about can we, for the local instructional theory, can we describe the characteristic of different kind of students like high, moderate, and lower ability, rather than doing the cycle in another class gitu. So we
Okay. Pak Usman, I will come back to your question. I put it on hold for a moment. I will answer it shortly. I will answer it shortly. So, first, what does this cycle mean? I start with a problem. The problem can be translated into a question. My problem is students count objects, not jumps. That's a good problem. So, how come and how can I change it? And what is the theory behind the change? That is what I start with. So I start by really writing down what I know. If I'm a teacher, I write down what I know about all my children. Novi is very concrete. Well, most of her solutions are very concrete. Noor is very abstract. And so I can talk about my children. I also know that Novi counts on her fingers and Noor counts in her head. That's already important because that's different children. I know about what the difficulty of counting is. I know that the move between counting to doing mathematics. I know in mathematics how it is difficult. I've seen theories about number lines. I've seen this, and I write everything up that I know. Not only since you write everything down, but in reality you would wish that you could write everything down. Everything you know. That is that knowledge. You also write about the problem. What do I know about the problem? How have I analyzed it? What have I seen about literature there? What is the real problem? And given everything that I know, I code design. That's the philosophy. And designing is, I dream what could be a solution. And I think of everything that can go wrong. So I have an idea of an investigation or a series of investigations, and I deeply think about what will happen in class, what can go wrong. The biggest nightmare. And as soon as I have a nightmare, I have to redesign. Because if in my head it still goes wrong, it's not something I can try in class. So I'm making cycles. I try something, I talk, what do you think will happen if I do this? I try it again. And I do that a couple of times. Still, I have something that will work. It works in the context. Context is supporting children. It works in the mathematics. I do that cycle many times. And then I go to Pazul and I says, this is my plan. Pazul says, why do you do that? And you explain your theory. You explain what all the difficulties are. You can defend your plan. I write down what I think will happen in class. All my hypotheses, detailed. If I'm a very good teacher, I write that I think Novi will do that, Noor will do that, Fiona will do that, Usman will do that. If I'm not such a good teacher, I say, I expect that some children will do this, some children will do that. I expect that I see this, I expect that I see this. If I see this, this is my answer. Ideally, you know, different responses to what happens in class. The more you can predict, the easier it is to reflect. And so some of the people at the Frontline Institute really write down all those episodes that they think are crucial in the development. And they try to be as precise as possible with possible mistakes. Master students find thinking about mistakes extremely difficult. They always write about students who do everything correct. And we know that is not reality. But the more I describe, the more I can reflect. And so I go into class, and maybe I'm the teacher, maybe not, and the teacher adapts, because something happens and the teacher changes from your plan. That is what teachers do. They might all of a sudden start talking. Or they might change the context. Or something happens. But now you start to reflect. Your reflection is based on everything you expected. If you didn't write down what you expected, you cannot reflect. And everything that you expected, you can now say what happened in class and why. And there it is interesting, because as soon as you say why, you start building the theory further. And now I have new knowledge, and I can do it better. Or I have new knowledge, and I can create the next episode, the next investigation. And at the same time, I can talk about what my theory starts to be. Now, I hope that, I don't have that here. Yeah, this is the one I want to go. So, if I do those cycles, now I start to build elements of my local theory. Conjectured, it's not complete, it's partly. Every time I develop a little bit more of my theory. So if you have analyzed everything and you know more, you should also be able to think about what is the big philosophy behind my ideas. That is a local theory, not that it was successful. And like I said earlier, in half of your readings, the local theory is it was successful. That is not a local theory. The local theory is what I did is that I moved from counting objects to measurement. And important was this element in the measurement activity and these discussions that helped students to make the move. And I slowly start to write about all those ideas behind my dream. And the more cycles I make, the richer my theory becomes. Why is it local? Go back. Wants to. If you look at theories, then you can have very general instructional theories. Group work is good for children. Cooperation is helping students to learn. If students talk, they remember more. You can have domain-specific theories. Theories about mathematics education. And then you have the local instructional theory. That is that transition. If I want to help students at 1/3 and 1/4, creating context that helps students to work in whole numbers and making the move back are extremely helpful. And then a teacher is reading that, and the teacher says, yeah, but my children don't understand her context, but I can use this context. If your theory is very good, the teacher is not depending on the context that you describe, but is listening to the theory. Oh, I have to think of something that will force children to go from fractions to whole numbers. I use roll of cookies, because my kids eat those cookies. They know there are so many cookies in. That will help them to do it. They all know this package in my hometown. Nowhere else that is sold, but in my hometown that works. Paul Kopp did measuring with feet in a classroom. Other people were measuring small and larger pieces of paper with Unifix cubes. The philosophy was the same, it was measuring. Some people had children measure with hands. The philosophy was the same, it was measuring. But the context was different every time. Now, the difference between context and theory is extremely important. And I think in 75% of your papers, I was reading about context, not about theory. To be honest, I don't care about the context. I want to understand why it works, not the context. Because your dance context is not working in my country. Your dance context is not working on Bali. So if you want to influence teachers in Bali, you want to innovate education in Indonesia, you need to describe it one level higher. And if your question is about how does it work in this context, I have a problem. That is not what the question should be. So almost every one of you need to think one level higher. That's difficult, but that's why you do a PhD. So I'm not saying it's easy, but that is the challenge you have to go to. Of course, you do it in your context. But your description needs to be such that other people will say, I don't understand that dance, but I can do this. Local instructional theory is the explanation why it worked in your context. So that is not written in context terms. It is written in higher level terminology. design research is not an easy study. You didn't do the most easy methodologies. It's much easier to do statistical research with a number of questions. But statistical issues with a number of questions will never change education. Design research might change education. How are we doing on time? 7 minutes left. 7 minutes. 2 minutes after 11. So 7 minutes, so let me finish almost here. Have you ever heard of Marty Simon? Does the name Marty Simon tell you something? People don't know Marty Simon. Marty Simon did write a few very informative articles. And an article in 1995, he wrote about hypothetical learning trajectory. And this is what he wrote about. And it helped to understand that design process. In an article in 2019 or 2020, he wrote about his research with a small group of students. And so that is also very important, and I think it's very good to read those two articles. Now, in this, he describes his idea of hypothetical learning trajectory. So, if you look at it, where's my mouse? Pointer. That's interesting. It disappears. It's last. He says again, teacher knowledge, that's decay of that cycle, and then he says hypothetical learning. What he says is the teacher has goals. I want that my children can add fractions, 1/3 and 1/4. Then I start planning that. So I think about what my plan will be. And I have a hypothesis of how that will go in class. And because I dream is a nightmare, I go back, and I go back, and I go back, and I go back. So that is something that switched 17 times. You are a genius if your first idea about the context is something where you think it works. And if you are that genius, please let me work with you, because I want to learn that. I have never been able to come up with an idea that immediately would be successful. And I'm pessimistic, so I always think it will go wrong in class. And I always need a partner to talk to. What do you think about this? What do you think about that? And often I talk to 25 people. And you're lucky because look at this group. So many partners. You need each other. So he goes back and forth, back and forth, back and forth. And then he tries it. And Marty Simon tries it in his later article. He tried it with 2 students. In my work with master students in Zodo, we did it in a group of 3 students. The Umum students, we asked them first do it with a group of 4 students. Then do it with the whole class. So there are many different ways to, back to your question, there are many different ways to do it. You can first try something with a kid in the neighborhood. Or maybe one of the parents in the neighborhood. And so you know more or less what you might expect. And then you do it with the whole group. And so your interaction, you look at what happens in the students' mathematics. You look at the interaction in the class. You come to Ilma's research on norms in classrooms. Because the norm decides what happens. You started to talk when I give an answer, and immediately I put down my norm. We don't shout in my classroom, because I want them to think. That's a norm. I asked, what did your neighbor say? Let's do that, because my norm is I want people to talk. So, the norms in the classroom, it might kill your research. And often you write about those two together. Did you remember the article Paul Kopp and the others? It had a combination of those two. And so he does all that together. And then he says, now I have new knowledge. Recognize steps of our design cycle. He described it differently. Let's stop here for a moment.
Okay. One time.
Yeah. I'm well trained. So, like I said in the beginning, I say, let's stop here, now I talk on. Like I said in the beginning, I cannot answer all your questions. Think about, what did I already answer? Because some of your questions has now been answered, but very indirectly. I didn't say, you asked me that, this is your answer. But indirect, I've answered a number of your questions. So when you come back, realize what has been answered or kind of answered, and what are the things you really still want to talk about. There are a few more things I want to talk with you as a whole, and I have a few more reflections on all the things you have done, and then we spend some time on individual questions and answering them. So that is more helpful if you don't read just your question, but if you think at a higher level. Maybe your question changed because of this. So after prayer and during lunch, talk to each other and think about what is it that you really want to know now. Yeah? See you. What time do we meet again? Basil? What time do we meet again? 13:30. Yeah? Looking forward to it. See you then.
Thank you for our speaker for the lecture. And now we would like to express our sincere appreciation for our speaker. As a token of appreciation, we would like to present the certificate to Dr. Dolk. Please, for the committee.
Foto. Ini lagi. Video.
Oh, yeah.
Satu, dua, tiga. Satu, dua, tiga. Oke.
Thank you.
Satu, dua, tiga. Satu, dua, tiga. Satu, dua, tiga. Oke, next.
Okay. Oh.
Ada dua ya?
I think I know what's in here.
Ya. Open it.
Open it.
Foto dulu, foto-foto.
Foto-foto waktu dia buka.
Atau video.
Video.
Foto dalam hati banyak.
Ah.
We have to wear it the next CDR. Next CDR you have to wear it.
But the sizes could be different.
Yeah.
XL here.
Indonesian size.
That's Indonesian size.
Yeah.
Spazoen XL?
XL.
Yeah. Oh, yes.
When you have to wear it, opening the next CDR.
Itu tak sesuai.
And tricky, right? I have to remember. I never wear a tie. Find the nice thing about being retired is you don't have to dress up anymore. And a notebook. Yes. And a beautiful bag.
Okay, thank you.
Thank you.
Mari kita pulang. Kita pindah ya.
Ya, Bu.